Welcome to this presentation on fraud and anomaly detection using Oracle Advanced Analytics option. This is part 1 where I'll cover concepts, and then I'll have a follow-on part 2 where I'll go into the actual demonstration. Hello, my name is Charlie Berger. I'm the Senior Director of Product Management for Data Mining and Advanced Analytics at Oracle Corporation. This is our legal disclaimer, which we're obligated to show in every public forum. And so fraud, this is an example that came up a couple of years ago that I thought was quite interesting, where it was the largest federal healthcare takedown in the nation's history at the time. I'm sure there's probably been larger ones since. But the false billings to defraud Medicare totaled $225 million, and this was a takedown on a number of different doctors, nurses, and healthcare executives. And what's interesting is the quote from Catherine Sebelius talking about for every dollar the federal government spends in its healthcare fraud and abuse control programs, it averaged a return of investment of $6.80. So the point being that there's a lot of fraud and abuse, but there are tools and techniques to combat fraud, and we'll try and cover this here. Now there is the American Society of Certified Fraud Examiners. It's a very prestigious organization that has been noting different ways to detect fraud and actually publish this list of 20 ways to detect fraud. And they talk about unusual behavior, where the perpetrator will often display unusual behavior. They'll talk about complaints, they'll talk about excessive voids, missing documents, a number of different things to look out for, right? So this all seems pretty easy, huh? But in actuality, trying to implement this, it's actually quite difficult. So you need to go beyond just human ways to combat fraud. You need to go to more automated, data-driven ways to combat fraud. Now here's my own personal example. I don't know if you can see the fraud in here, but this is actually my own personal credit card statement from a while back. And if you look at this, you might say, well, where's the fraud? Is it the Monaco Cafe? Was Charlie really in Monaco? Well, yes, I was actually, and that was for business. So that's not fraud. If you look here, these are gas stations. Now, we don't know where these gas stations are, but if we did look up that data, it would turn out that this is in a location in Connecticut that I have not been to for over 5 years. I'm based in the Boston area, and I just haven't traveled through that part of Connecticut. Looking a little bit further, you might see, well, at a gas station he's spending $75. That's an awful lot for gas, but notice they're all exactly the same amount, $75. Looking a little bit further, they're in pairs of $75 pairs. They're 1 minute apart, so there's 2 or 3 of them here, all 1 minute apart. And if you looked at my if you use the SQL windowing functions in the Oracle database, for example, and you looked at my total purchases for gasoline over the long window of time compared to my most recent consumption of products at gasoline stations, you'd see quite a jump. So that's where the data would drive the signal to say, something unusual is going on here. So here's a customer's story. This is Turkcell, one of our customers, that actually uses Oracle Advanced Analytics option to sift through their data in a very rapid way. They have very, very large amounts of data, but they're looking for anonymous prepaid phone card fraud. And it's a wonderful story. It talks about the total amount of savings they get from those efforts. And so we have functionality that addresses this. It's called the Oracle Advanced Analytics option, and it involves a number of algorithms and techniques that we've added to the database. And I don't know if you recognize those gentlemen on the right-hand side, but these are all different famous mathematicians, famous statisticians, famous scientists. And you'd see Gauss, you see Vapnik, you see Sir Edmund Fisher, and so on. And these esteemed individuals have all developed mathematical formula that we've put inside the database, all except Einstein at the bottom. That was a wild card one that I threw in here. So what we've been doing is moving that inside the database, and now the database knows how to do these very, very advanced computations. So we've really turned the database into a comprehensive advanced analytics platform that we say is the fastest way to turn data into actionable information. And so we have product functionality. It's called the Oracle Advanced Analytics option. It's very powerful, it's very easy to use, and it provides an enterprise-wide platform for doing predictive analytics. So I'll cover that more in the demo in part 2. So we're looking at data mining, the concept of automatically sifting through large amounts of data to try and find previously hidden patterns and develop insights, and in fact maybe to make some predictions. And we're looking at the second one from the bottom, the find fraudulent or rare events. This is a special technique called anomaly detection. And what we're trying to do is, when we have lots and lots of data but very, very few examples of what we're looking for, you can't really fit a line through that data. It's very difficult to make a predictive model that locks on something that, when there's not too many things to lock on, when there's very few rare occurrences of what you're looking for. So what we're doing is we're looking for needles in haystacks, and haystacks are usually big. There's lots and lots of data, and the needles are typically very, very small, and they're very, very rare. So what we do is we look for what's different. We look at what stands out about that data. And here, just on a X1, 2, 3, and 4 concept, we're going to look at individual records and individual attributes like age, income, time of day, what state they're from, how much the dollar amount was for, and so on. And taken individually, they may stand out a little bit, but not so much. But if you take them in combination, you see this situation where they're all at one end or the other of the spectrum. They stand out collectively. They stand out as being a little bit different. So that's really what we're going to do with the anomaly detection algorithms. We're going to sift through large amounts of data in an automated way. So I'm always reminded of my famous statistician George Box, who says essentially all models are wrong, but some are useful. And here, as Catherine Sebelius said, for every dollar spent, we get $6.80 of value. So we're going to look at the Oracle Advanced Analytics option, and to do this, just to solve something like, say, tax fraud, we set up a workflow. We set up our data. We might look at our data. We build some models. We apply that model to some new data. We might build some additional anomaly detection models, but we basically drag and drop these nodes onto our workflow palette and build predictive models. And prior to building the models, we may want to visualize that data as we show here, and we can kind of look to see if there's any patterns. Now the idea is, it's probably complicated. If it was that easy, you would have been able to figure it out, but we're going to use more automated techniques. Here we're going to use something like a decision tree. Now, in the actual use of fraud detections, we might go to more complicated techniques, such as our one-class support vector machine algorithm, which is designed specifically for trying to find very, very rare occurrences. But here's something that's easily visualized. Here is the anomaly detection algorithm showing for some insurance claims data how we look for these rare events, these little spikes, these things that stand out, and then for those models we can visualize the attributes and their relative importance in making a prediction. Now the nice thing about doing this all inside the database is it's very easy to set up more sophisticated, more complicated analytical flows or analytical pipelines. And here we do our simple model flow where we take our claims data, we build a model, and then we apply it and we rank and sort these as the most suspicious claims. But here's another concept. We take and do a clustering model and we assign the records to more homogeneous subpopulations, and then for each of those different subpopulations, like infrequent high amount claims or repeat claimants, then we build separate anomaly detection algorithms on each of those and then flag those records. Here's how we would do it if we were just using the API and going straight into code. And by the way, with the Oracle Data Miner GUI that's part of SQL Developer, we actually generate this code automatically for you. So in this case, it all runs entirely inside the database. It's a very fast performant predictive model. And we have a whole suite of different algorithms and techniques that are available inside the database. We've been primarily focusing on the anomaly detection algorithm in the center, the clustering algorithms, and the classification algorithms at the top. But you can use these in isolation or in combination to solve very complicated problems. And here's a potential way you might do that. Just do the anomaly detection as a single model. You might do the classification techniques or the clustering, or do a hybrid of number 3 and then number 1, or you might even do a panel of experts. I want to launch 5 or 10 or 20 different models. Why? Because you can do it. It's fairly easy to do these types of things inside the database. And so really, if you think about how easy it is to build these models and make the database, turn the database into an analytical platform, it's pretty easy to build applications, and that's a little bit of what we've been doing at Oracle. So we have something called the Oracle Adaptive Access Manager that, again, is looking for fraud, and not to go into the details, but based on your logins and your attempts and your devices and your browser and the time it's been since your browser, we use clustering. We assign you to your typical cluster behavior segments, and then when you come in exhibiting some sort of behavior that's non-traditional, we flag you in real time, because these models are in fact real-time models. Here's another similar situation, or similar application. This is doing spend classification. So based on your purchases of, say, flat panel monitor, and it gets filed away with a text string that says flat panel monitor, but it gets put in the bucket of, say, meals. Well, we say we don't usually see the words monitor, flat, and panel in the bucket where it says meals, so we use the text mining to flag it as something that probably is misfiled. And it could be fraud, it could just be a mistake. So in the next segment, I'll cover the actual demo of this and cover this live. But if you want to get started, you can Google to Oracle Advanced Analytics and go down into the Oracle Data Mining free Oracle by Example training. You can send me an email, and I'll be happy to send you my favorite links, which have the links to many of the different resources. So with that, this isn't really the forum for any Q&A, so I thank you for watching this YouTube video. Stay tuned, and please watch the part 2 where we'll cover the actual demo. Thank you very much.